Part C is where we actually have to use some calculus here, because it wants the rate of change of the predicted number of new customers at week 1 and week 6. So we need to figure out n prime of 1 and n prime of 6. So let's take that derivative. So n of x, I'm going to rearrange this to become 500 x squared times the square root, which is 280 plus x squared. Now the square root means to the power of 1/2, and we get to the power of -1, so this can combine together to equal to -1/2 plus 10x. So that's just using the normal exponent rules. Now I'm going to figure out what n prime of x is going to be. I'll get my first part here, which will just become 1000 x times 280 plus x squared, and still to the power of -1/2, plus, but this becomes a minus. Now the 1/2 comes down, so this is where it becomes tricky. So I'm going to do this all in, I'll split it into 2 steps. So I get 500 x squared. Now this negative is already here, the 1/2 comes down, and I'm going to get times 280 plus x squared to the power of now -3/2, because that's 1 less than -1/2. Now times the derivative of the inside, which is just going to be 2x. And then the semi-annoying part is that we have this plus 10x over here, so at the very end we get just plus 10. Now these are long and complicated. I get square roots, I get cubed and then square roots to the power of -3/2. It's on the denominator. So I'm going to use a calculator to help me with this. N prime of 1. See, plugging this into my calculator, I get 69.5. 69.5. And n prime of 6, I get 328.3. 328.3. Now these aren't exact, these are rough estimates because I don't want to carry so many decimal places. But those are the rates of change at week 1 and week 5 in terms of the new customers.